Hello, everybody. My name is Matthew Hepler. I work for Appalachian Voices. And today I'm going to be showing you Google Earth Engine. And so let's go ahead and get started. So first and foremost, I want to start off by telling you that the link to this video will be made available to anyone who registered for the workshop via email. The reason I'm doing that is I want everybody to just kind of focus on this video for right now. Don't really worry about trying to keep up with the code unless you really want to, but just having this video available for download will allow you to learn at your own pace and code at your own pace as we go forward. These three links are also going to be available, so if you, I will chat these links into the comments of Zoom, and you should be able to download this presentation that I'm giving you now. The code repository, which will automatically import the pre-code or pre-processed code that I have already written for you in this link. And also this third document down here is the text of the code. So in case if for whatever reason the repository doesn't work for you, you can download that document and copy and paste the code text into Google Earth Engine, and hopefully it will work for you that way. I don't know if y'all remember the For Dummies books that were really popular about 10 years ago, but those books always began with a foolish assumptions chapter, which basically say the assumptions that I'm making about all of you and like what you want to learn. So I'm guessing that most of you are affiliated with some nonprofit or environmental project in which satellite imagery could be a benefit to you. That's why you're on this call today. And I'm also guessing that you have no GIS or previous programming experience and are still interested in learning more about how to access satellite data for those projects. Or you have some GIS or programming experience, but don't really know about the Google Earth Engine platform and what all it is capable of. So before we begin, I want to go over some basic concepts. So you'll probably hear me use several of these phrases throughout the lessons. So I'm just going to go ahead and define what they are right now. GIS stands for Geographic Information Systems. That is a conceptualized framework that provides the ability to capture and analyze spatial and geographic data. Very often geographic information systems are used to create and display interactive maps. Web maps have become like the most common aspect of this. Remote sensing is the process of detecting and monitoring physical characteristics of an area, typically from a satellite or aircraft. So satellite images, images from airplanes, those kinds of things. So Google Earth Engine, it has a very large amount of remotely sensed data. Raster data is a data type that is used in GIS. It is any pixelated or gridded data where each pixel is associated with a specific geographical location. So that in this instance, we'll be talking about satellite data, the Landsat and Sentinel satellites, and each one of those pixels represents a spot on the ground. JavaScript is an object-oriented computer programming language commonly used to create interactive effects within web browsers. So I'm going to be showing you, or I'm teaching you JavaScript in the Google Earth Engine code editor today. And then Google Earth Engine, well, what is that? Well, Google Earth Engine is not Google Earth. Many of you may be familiar with Google Earth Engine's counterpart, Google Earth. It's much more popular. It is a geographic information systems platform that lets you look at the entire planet. Well, Google Earth Engine is kind of backbone of Google Earth. That's where the original imagery comes to get processed that eventually makes its way into Google Earth. But Google decided to open that up to the general or to the nonprofit world, and as well as researchers and academics. So Google Earth Engine is this huge library, a multi-petabyte catalog of satellite imagery and other important GIS data with planetary analysis capabilities. Well, what does that mean? Well, Google Earth Engine allows you to process data on Google's servers, which means it's very, very fast and allows you to like process information that you would not be able to do on your own computer. Google makes Google Earth Engine available for scientists, researchers, developers, and nonprofits allows them to detect changes and map trends and quantify differences across the Earth's surface. As I said before, I typically use this to monitor mines, subsurface mines in Central Appalachia. So let's go ahead and get started. Here is the link. So I am hoping I'm going to go ahead and chat this link into the code, into the comment section again. And hopefully if y'all have already registered, you can click this link and it should take you into the Earth Engine platform. And you should see something that looks like this. Now, hopefully all of you have pre-registered. This Google Earth requires you to register for this service. So if you did, that's great. I'll give y'all a moment to just kind of catch up with me. Like teaching coding by a video is kind of a odd process. So you're just gonna have to bear with me. But I'll give folks a moment so they can get caught up. And hopefully they are seeing something that looks like this. All right, so we're going to go into the lessons now. Again, I encourage folks, try to keep up as best you can, but do not worry if you're not able to do so, in that this video will be going out, so you will be able to learn at your own pace. And at the end of the lesson, I'm going to send out several other learning resources as well. So in keeping with programming tradition, we're going to go into lesson 1, which is called Hello World. Literally every programming, or not every, but most programming lessons do start off with some version of this. And here, we're going to write a very simple program that is 2 lines of code. We're going to declare a variable called X that is a string of a set of characters. And we are going to make this program print that phrase, hello world. As I said, most lessons, programming lessons start with this very, very simple program. So we're going to click run, and we see hello world prints out here over on our console page. So that was fun. We have just interacted with our first line of code. However, that is not particularly useful to us. So let's move on to lesson 2, which I have called Hello Data. Now we've moved from 2 lines of code to 14 lines of code. And just to explain a little bit of what's happening here, we're declaring a variable. That variable is pulling a specific Landsat image. So Landsat is a type of satellite that's been orbiting the Earth for the past 30 years. The next section of code talks about how to display some of what are called bands from that satellite image. and then it sets the center of the map and the zoom level onto a site. So let's just go ahead and hit run and see what happens. We have zoomed in on San Francisco. Now, I mean, this is all very well and good, except for the fact that it is very likely that you're not going to actually know this file path up at the top that contains the image that you want. So I'm going to address that actually in the next lesson, but this particular set of code does give us a framework to kind of explain what is, well, some of the aspects of the program and what all is going on. So you can see here, we have this layers tab over on the left, which we can turn on and off. When we turn it off, you see this is very similar to a Google Maps framework. So I'm assuming most of y'all have probably used Google Maps at some point in your life. This then lets you add this layer, this satellite layer on top of it. We can zoom in and out, go see how far it goes. And what else can I show you? Yeah, so we have the console and we have the inspector tool here. So if I go to click on the inspector tab and click on a link, I can get information about so what are all of these things? These are all different bands that are associated with the Landsat image. There's a website I have found that explains the different bands and band combinations that are measured in particular by the Landsat satellite. So band 2 is blue light, band 3 is green, band 4 is visible red. But satellites can also measure out the electromagnetic spectrum outside of what the human eye can see. So band 5 is near infrared, and there are several other infrared measuring bands out there too. And then on the lower end, there's also this band 1 that is used for measuring aerosols, which again, the human eye cannot see that. So you can create these bands in various combinations. And for the Landsat satellite, natural color is the bands 4, 3, and 2. Whereas if you wanted to do an infrared image and look, which is kind of more useful for spotting vegetation, you can switch it up and do these 5, 4, 3. There are other band combinations that are also useful. Short infrared, and these band combinations are used for agriculture, 652, 762 for highlighting various geologic features. If you're doing bathymetry work, 4, 3, and 1. I mostly stick with the natural color and the color infrared though. So moving back into our lesson. So if we wanted to switch over to the infrared, we could switch this to bands 5, 4, and 3, and pick up this false color infrared image. And actually we should fix the label of the layer here too, so false color. Run that. And I'm gonna fix our zoom level 2 to that. See, with programming, things are very often very precise. If it will yell at you if you don't get your semicolons in just the right place, as I just demonstrated there. Here we have a nice false color composite infrared of the San Francisco Bay Area. So let us move on to the next set of code, moving on to lesson 3. As I've said before, this is all well and good, but it is very unlikely that you will know the specific Landsat path to pull the data from. So let us change that by going to what is called an image collection. So moving on to lesson 3, we have a set of code here that defines a satellite. In this case, instead of Landsat, we're going with Copernicus satellite. This allows you to set a date range and also set a specific location on the map, and it will pull the satellite image from that location. So I'm going ahead and click run on this line of code. It's going to take you to a mine site just outside of Appalachia, Virginia. And here we have a true color image of a ridge just outside of Appalachia. This is a former surface mine. You can still see some active disturbance over here on the left. This is the Looney Ridge surface mine. On the console here, I also have this code print out the date that the image was taken, and you can see some information about the file path, stuff like that. So again, we can turn this layer on and off. So let's go over what this code is doing. So again, we start by setting the center of the map. We define what is called an image collection, which is, you can think of like a large stack of images across a time frame. It filters things within a specific date range. It then filters out from that stack the more cloudy images. So that is what this cloudy pixel percentage is doing. So if I bump this up to 30, it would produce a lot more images, but it would also, a lot more of those images would be cloudy. So I am going to keep that relatively low at 5 or 10%. It also pulls in those bands like before. In this case, it's pulling in bands 8, 4, 3, and 2. And it is only pulling images that are from the location at the center of this image. This code then displays the last image kind of in that stack and prints the date of that image and displays it. So, and we go in here into the settings. So click the layers tab. Because we pulled in multiple bands, like more than just the 3, we can change those here. So I can change this to 8, 4, 3, hit apply. And then we get the near infrared band stack, and can see the infrared portion of the spectrum, which is a lot better for kind of discerning disturbances in vegetation. We can see the formerly mined site over here. This area is in a state of reclamation, and this area was disturbed until recently, is now starting to reseed. So let's move on to the next set of code that is actually very similar. Well, actually, before I get there, we can alter the date of the images here. So here, the date goes from 2020, September of 2020 to January the 20th. Like if we wanted to update that to a more recent image, we can put today's date in there. And see if we can get a more recent image. But because of this cloudy percentage thing, if say today was a very overcast day, you may not get an image that corresponds with today's date. So this image is from 4:09. So couple weeks ago, but still fairly recent. And again, we could probably get a more, well, if we bump the cloudy pixel percentage and we're more tolerant of clouds, let's go ahead and try that. We may get a different image as well. So let's bump that up. We can maybe be able to get that more recent. So let's bump that up to 50% and see what happens. Yep, and there we see we get a new image, but we also a more recent image from a few days ago, but also a lot more clouds. So that is less useful to us. So we'll go back down. Means we have to go further back in time. Now this Sentinel satellite circles the Earth fairly frequently, every couple of days. So you can get more information about these satellites by going to the Google Earth Engine and going into the data sets and learn about all the different satellites. So we can learn about Sentinel, and so we're in Sentinel 2. Learn thing about its orbital period and how many bands and lots of other good information in here. Let's see. There's the different bands that the satellite can detect. Properties. And you also can learn like how far back in time you can go. So with this particular satellite, you can go back to 2017 with the data imagery. Somewhere in here is orbital period, but I'm not seeing it. Anyway, I'm going to move on to the next set of code. So this set of code basically does the same thing as the previous. However, instead of setting the date, it has some additional lines of code that enter in today's date and will always pull an image collection from a 4-month window from today's date. So this is useful if you want to always essentially have, you don't have to keep updating that date field manually. It's always going to pull today's date to get the most recent image. And again, it has the same parameters of most recent cloud-free image. So if you're willing to be a little more tolerant of cloudy images, you can adjust that accordingly. All right. So moving on to the next lesson, into lesson 5. I know I'm moving fast, but again, this video or this recording will be available for you for your own use later on. So yeah, don't worry about that so much. Just go ahead and watch and enjoy, and you'll be able to watch this later if you want to keep up. So, okay, so that takes us to lesson 5, adding shape files into our data, and in this case, mine permanent boundaries. So this algorithm is basically going to do the same thing as the last, except it's going to display a mine boundary, which most of the state agencies have their mine boundaries in various shapefile or various GIS formats, including shapefiles. So here, when I click run, we move to a mine just to the north of where we were. This is permit 1101914. You can see the layer displays a false color composite image, and it also displays this mine permit boundary in blue. Turn the layer on and off. We can turn the permit boundary on and off. You can also switch this to true color by going into the settings. Changing the bands around. Something we're a little more familiar with. Again, we have the date. I'm actually going to change this back to the false color. And all right, and taking a look at the code, you see we have this variable called mine feature 1 that is brought in as an asset, and it is then displayed on the map. Now, how do you bring in an asset? Well, as I said, like these shapefiles are available by most of the mining agencies, and shapefiles is a really common GIS format. So if you have one, you can go and want to import one, you can go over here to assets and go to new. Then you have the option of uploading a GeoTIFF, which is a raster format, or shapefiles or CSVs, which are also common GIS formats. So I click shapefiles, I click select, and I've got a folder here with a shapefile in it. This is a different permit, 1101954. I'm going to click open. And shapefiles consist of multiple parts. You're going to need to remember to bring in the projection file, the DBF, the SHX, and the SHP file. I'll go ahead and click upload. And I'm going to move over here to my tasks tab, and I can see that the file is starting to upload and upload the data. So when that is complete, that file will be over in our assets, and I'll show you what that looks like bringing that file in. So just let's give it a second to run, and we will 5 seconds. Last one taking over a minute to load this file. Took right at a minute to load that file. Go over here to assets, hit the refresh button, and I can see that that file has been loaded, and I can import that into my map too. So click the import button. It has been brought in as this variable table. I'm going to rename this code mine feature 2. Then I'm going to change my code here to change from mine feature 1 to mine feature 2, and hit run again. And you can see a different mine site gets shown with the different boundaries. So this code like centers on whatever mine site that I tell it to. So all right, so moving on to the next lesson, I'll go back over here to my scripts. again, basically this is the same code yet again, but with one extra feature down here, which allows us to export our image. So this is export, this set of code allows us to export our data that we have into a Google folder. And what this block of code does is, well, go ahead and click run. Again, it's showing us, since it's a new script, it's showing us the previous permit boundary, but that's fine. Then it creates in our tasks tab, which was highlighted just a second ago, it creates this process. So because we have this block of code in here, we can now click this run button. And so it is saving it. This will save our data into our Google Drive, which is Google's cloud storage platform. And you can give the task a name, and you can, this is your file name down here, so you know where to find the file in Google Earth. So I have set the code to put the file name as the date, but you could change it as mine site or something like that. And then you can click run. And then this code will download into your Google Earth engine, your Google Drive folder, and you can then export it out to other GIS platforms like QGIS or ArcGIS. Or, I mean, actually, you could even just open it in a simple photo editor too. So anyway, that's going to take a few seconds to run. So we're going to let that happen. So the process has finished running. And if I go down here to my Google Drive, I see I've created a folder called Mine Sites, and then the image is inside of it. Which I can then use to download and import into various other GIS software platforms. So now that I have shown you how to download data with block code export to image, I'm going to take you on to the next lesson, lesson 7, it's mislabeled here, called the Landsat Explorer. So this is actually a completely different block of code than the past three bits. I have basically taken this code from the examples and just put it into this lesson. If you scroll in your scripts field all the way over here on the list, scroll all the way down, you should see a whole bunch of different kinds of examples. There are numerous examples that explain a ton of different, well, basically free starting places to take code and play around. And one of those is the Landsat Explorer. And so I can actually enter that in here. Search for that. See if it comes up. Here it is in the user interface. So I'm going to actually go ahead and clear this script and just run it off of this. So again, this is just an example that Google provides for you. And we'll just run the code from here. We'll click run. So this set of code, kind of like the last one, is just essentially creates a Landsat download tool. So some of y'all are probably just interested in the data and accessing Google Earth Engine for the data that it has and not so much interested in doing the coding through Google Earth. So that's why I wanted to show you all this tool in particular. But similar to the others, you have filters for date. Go 2019, 2020. And then from that, you can select a image to choose, and you do the natural color, the false color, and you can click this button. You can also get an export to export that to whatever folder that you wish in your Google Drive folder. Okay, moving on to our last section of code. Okay, so this is the last section of code. I wanted to share this section of code with you, predominantly because it deals with various pollutants such as methane or nitrous oxide. I'm going to go ahead and hit run with this code. Up until now, we have primarily focused on satellites that produce data, like satellite imagery as their data source. But there are other satellites out there that do other things like measure elevation data or like look for specific pollutants, which is the case with this particular satellite right here. And so as I click run, we can see it displays this worldwide display of pollutants. If we look at the code, it's very similar in that it has a date that we can change the date parameters on if we wanted to, and kind of change the window of time for which we are recording data. Since it is not based off of imagery, the data gets displayed through this palette, which we kind of control. Black, blue, purple, cyan, green, yellow, red, with red being the highest there. And well, I guess the cartography or the cartographer in me wants to tell y'all to well, choose your color palette responsibly. I mean, if we wanted to, we could make this only run from yellow to red and make this map look way worse. So let's just see what that looks like. Yes, if you do this, this would be an example of a bad map because it makes things look much, much worse. So yes, control, yeah, be responsible when you use your palette, use lots of different colors, but let's reset that. Anyway, I also labeled this lesson Steal This Code because I got it directly from the data sets, from the Sentinel data set. And tropospheric monitoring instruments. And so we got the different pollutants here: carbon monoxide, formaldehyde, nitrogen dioxide, ozone, and methane. And when I go into that, go down here and just open in code editor, and lo and behold, the code was there already written for me. So I mean, Google has lots and lots of examples like that for you to play around with. I would encourage all of you to do that. Okay, well, that is it for the coding portion of this session. I did want to show you a handful of other projects that are currently using Google Earth Engine. This one right here is from Google itself. I think they partnered with Carnegie Mellon on this. And as I believe this feature just became available on Google Earth last week for Earth Day, but it is this time-lapse feature where you can see lots of different things, including glaciers retreating over time, mining in Alberta, Canada. Now I've actually done this for mining in our area as well. See that on the Appalachian Voices website. One of my personal favorites, the drying of the Aral Sea. See the sea turn into desert over a period of time. Also worth mentioning is this climate engine. This group focuses primarily on climate and climate change data, change in weather, drought monitoring, wildfire, partnership with the University of Idaho and Google. They're doing they have some really neat tools as well. And bringing things a little bit more closer to home, SkyTruth, the organization SkyTruth also uses Google Earth Engine, and they have partnered with Appalachian Voices on a couple of projects looking at coal mining in Appalachia. One of those is this SkyTruth MTR data file, which you can use to download basically mine disturbance over time. So you can see how mine data or how mines have impacted the landscape over a period of time. And even more recently, right now we've received a grant from the National Geographic to produce a mine reclamation data set. So that's taking that mine disturbance and to the next level. It's trying to classify how well mines are reforesting over time. I hope to be doing a webinar on May the 26th on that very subject, so I hope you will join me for that. Also, here is a series of links that you could use to learn more about various things. So that one link teaches you teaches you JavaScript, Google Earth. I already showed you the code examples on the Landsat Explorer, but there's numerous examples there that you can use to kind of use your base and learn more about the program. Google Earth Engine also has a number of tutorials there at the link that I've displayed there. And also there is a YouTube channel that is dedicated to Google Earth Engine lessons. So I will leave it at that and open the presentation up for questions.